you were just experiencing and exploring the force of gravity with the PhET simulations. Well, what is gravity? Nobody knows. It's the weirdest thing. Nobody knows what gravity is. All we do know is what we observe. And Newton observed a long time ago that very, very large objects like the Earth and the Moon have gravity. Nobody ever thought that little bitty tiny objects have gravity associated with it, but they do. Because Newton was able to show that all matter has a gravitational attraction. All objects have gravity. And Newton was able to show, and I don't know how to derive this for you, so all I'm going to do is put the equation up here. The force of gravity is equal to this big G times the mass of one object and the mass of another object all over the distance between those two objects squared. Have no idea how he came up with this, but Newton was an expert at observing nature and applying his mathematical skills and finding a formula that fit what was going on in nature. Okay. This is what we call big G. It's just a constant. It's a number. It's a number. 6.67 times 10 to the minus 11. This is the mass of one object in kilograms. This is the mass of another object in kilograms. And this is the distance between those two objects, the center to center distance squared in meters squared. Now, one of the first questions I get is, why is the distance in r? Okay? Well, if this is the Earth, and here's the center of the Earth, and I was trying to figure out what was the gravitational force on me by the Earth, which is kind of a curious thing because I'm standing right here and the force of gravity is working on me and it's keeping my feet on the floor. If I was to try to figure out what the force of gravity was, I would need to know the mass of the Earth and I would need to know the mass of me. I can figure those two things out. And then the distance between the center of the Earth and me, here's me on the center of the Earth, right there. Okay? There's me on the center of the Earth. So if I was to draw a line for the distance between me and the center of the Earth, what is that I just drew? That's the radius, right? That's the radius of Earth. So that is why there's an R there instead of a D, right? We use all different kinds of variable letters in all different kinds of ways. Okay. All right. So there is a force of gravity associated between any two masses of objects, and your simulator tried to show you that. So let's do a problem, and some of you still have your simulator up. I want you to go ahead and do that. Let's say that set the mass of the first object equal to 3 kilograms. And then set the mass of the second object equal to 3 kilograms. And then set the distance in between the two equal to 2 meters. And then what I want you to do is to calculate what the force of gravity is. Let's do another problem, one that's maybe a little bit more interesting. Let's find out what the force of gravity is on me. What force do I experience while I'm standing here on the Earth? Big G is a constant. Again, it stays the same. It doesn't matter what problem we're doing. It's always 6.67 times 10 to the minus 11 Newton meters squared per kilogram squared. You'll need to know some facts, and you could ask Siri this, or you could Google it, but we know that the mass of the Earth is 5.97 times 10 to the 24th kilograms. And we know that the radius of the Earth is 6.37 times 10 to the 6 meters. You don't know, but I will volunteer that my mass is 77 kilograms. So now you should have all the information, this is the given information, in order to solve what the force of gravity is on me. Stop the video, take a minute, and see if you can make this calculation. The force of gravity of the Earth on me is, I hope you got this answer, 755 newtons. Now, if you didn't get that, I want you to keep trying with your calculator until you get this number. One of the most common mistakes is that people forget to square the denominator. They may not remember how to put these exponent, these times 10 to the minus 11. I use the E button on my calculator, so I'll say 6.67 e to the minus 11 and 5.97 e to the 24. Make sure that you're entering things right so that you get 755 newtons.